Okay, we're going to consider our next example of using Green's theorem to evaluate integrals. So it turns out you can actually simplify line integrals. So a hard line integral can go to an easy area integral using, of course, Green's theorem, which we know as f dot dr equals qx minus py. So, and and our f is just pq. So the problem I'm going to consider is find the work done by the force F equals y minus cosine y, x sine y, along the curve, which is clockwise, x minus 3 squared plus y minus 7 squared equals 4. So this is, of course, a circle centered at 3, 7 of radius 2. Because it's clockwise, it's actually negatively oriented. Remember, just like angles increase counterclockwise, we like counterclockwise. And so this is actually, we'll need to use a minus sign. So, to do this, the work is just the integral of f dot dr along our curve. So, now what I'm going to do is I'm going to add a negative sign and use Green's theorem. The negative sign is because, again, it's going clockwise. And then it'll be qx minus py. And we can use Green's theorem again because it's a closed curve. Okay, so let's compute. Qx will just be sine of y, because q is just x sine y, while p is y minus cosine of y. So py will be 1 minus, or rather 1 plus, sine of y. Okay? So, therefore, qx minus py will just be negative 1. Okay? So our work, quite simply, just becomes the area of that region. And this, of course, is just the area of a circle, so pi r squared. Okay, so let's just briefly compare how we would have had to do that line integral. F dot dr is p dx plus q dy. So this would have been y minus cosine y plus x sine y dy. So now if we used the parameterization of the circle x equals 3 plus 2 cosine t and y equals 7 plus 2 sine t, you can see that we would have had to plug in x equals 3 plus 2 cosine t and y equals 7 plus 2 sine t into that nasty, horrible expression. So this would have been quite bad to evaluate. So this was pretty easy by comparison. So this should illustrate that sometimes green theorem is worth knowing. Thanks for watching.